There we go. Ready when you are.
All right, yeah. So yeah, thank you so much. And good day, wherever in the world you are. We're going to be talking today about the Tungsten Fabric deployment and just getting getting started with Tungsten Fabric. Tungsten Fabric, as you know, or maybe you don't know, is a fantastic software-defined networking solution for OpenStack and Kubernetes. We'll do just a call it 10-minute whistle-stop tour through the architecture and what we do and why we do it to talk a little bit about the various components that are going to get installed. And then we'll talk about the installation itself and where you can go for better resources and some guidance. Yeah. So you can find us online. The Tungsten Fabric community is, of course, a member of the Linux Foundation networking. So you can check out our wiki at the LFN. You can interact with us on Slack and our mailing lists. And then we have a weekly TSC discussion, which is the kind of now meeting point for all of the folks in the TF. That's on Wednesdays at 10 o'clock, and you can check out the Tungsten Fabric meetings website because we are, as usual, talking about changing that. Okay, so I mentioned Tungsten Fabric is an overlay SDN. Our goal is to provide networking to cloud orchestrators. So in our case, that's mainly OpenStack and Kubernetes, although there has been a variety of different orchestrators that we've dabbled with in the past, everything from Mesos to VMware. Regardless of where you find Tungsten Fabric, our goal is to rock up with the same set of services. So what we do inside of a cloud is to provide the basic routing and switching that folks are normally expecting, as well as load balancing and security. Normally, those orchestrators have some sort of load balancing and security framework. So we'll fit into, say, the floating IP framework inside of OpenStack or the Kubernetes services framework, and we'll implement all of the required ECMP and backend load balancing for those scale-out services. Similarly, for security, we'll implement things like OpenStack Security Group or Kubernetes network policy, and that's how we implement our distributed firewall. Tungsten Fabric is one of the exceedingly rare projects that has an extreme focus on performance. So not only do we have our kernel module data plane that we've spent a ton of time optimizing and adding performance to, but we also have a very robust DPDK data plane. And then finally, we've partnered with the likes of Intel and others to develop SmartNIC acceleration for Tungsten Fabric. I think in particular, the Intel N3000 code hit the repos very recently. I think that was like maybe a month and a half, 2 months ago. And so, yeah, it's super exciting to have so many options. I mean, we can push packets all the way up to a couple 100 gig if we're using hardware offloads. That's just awesome. And while doing that, we support all of the traditional networking protocols that data center devices are going to support, with a heavy focus on BGP, because, you know, that's what we find everywhere as a routing protocol. I'll just talk through my favorite slide really quickly to tie together all of those features to give you a sense of how overlay SDNs work, what they do, why they're important. In OpenStack, an overlay SDN was a choice. There was a lot of OpenStack networking solutions that used underlay networking or that used the provider network, tenant network model to create separation inside of the compute nodes. But there was still a ton of state that leaked down to the data center network. So if you created a network in OpenStack and you wanted to talk to that network, you would have to invariably plug it into your data center network. And Tungsten Fabric did a little bit something a little bit different. Tungsten Fabric uses tenant networks and overlays, and it creates tunnels between all of the various compute nodes in the cluster. So if you have, like in this example, green 1 trying to talk to green 2, those just so happen to be on completely opposite ends of the data center. But never you fear, Tungsten Fabric will create a dynamic tunnel and send that packet across the data center. And to the data center network forwarding that packet, it just looks like a plain, simple UDP packet. The encapsulations that we use are VXLAN, which at its heart is just UDP, or MPLS over UDP, which again, it's right in the name, it is UDP. But the cool thing about those two encapsulations is that when a packet from those encapsulations is received by a node that understands them, there's a field, either the VXLAN VNID or the MPLS label, that can be used to break out that traffic and figure out which compute, in this case G2, that message is supposed to be passed to. Turns out this approach is absolutely essential for Kubernetes because the Kubernetes networking model demands a giant flat network for pod reachability. And there are a lot of pods in a cluster. So if you were going to try and advertise all those routes down to your data center fabric, you either have really good network devices or not a lot of pods, because everything starts falling apart awfully quickly. So yeah, that's one of the main reasons in both Kubernetes and OpenStack that overlay SDNs are preferred. It keeps all of the configuration, the state, the awareness of everything going on in our clouds away from our data center devices so they can move packets as quickly as possible, and the cloud can plug in all of the VMs and containers as best as possible, and everyone can focus on what they're good at. One other scenario that's super cool in my favorite slide here is, like I mentioned, Tungsten Fabric enforces security policies. We do so using the security group framework or the network policy framework inside of Kubernetes. So we seamlessly plug into the orchestrator security framework, or we have our own security policies that we call network policies. Network policies are a blend of security and connectivity. If we want to, say, for example, permit traffic between the green network and the blue network, and every time I present this slide, I realize at this moment that I forgot to make the blue cloud blue, but the computes are blue, so I'm further ahead than I usually am. So yeah, I'm not going to make my usual awkward jokes about the yellow-blue network because it's just confusing, but sorry about the colors. But yeah, so the green network on the left and the blue network in the center, in Tungsten Fabric's network model, these are totally isolated. So each one of them will be a distinct, unique routing table. And to allow connectivity between them, we use our network policies to permit access. Well, network policies don't just need to be network-based. They can cover the whole 5-tuple. So you can create a rule that says, for example, only HTTP traffic is permitted to the blue network. Any non-HTTP traffic will get discarded. And most importantly, those policies are enforced or enacted on the interface of the VM or container, or on the first flow of the packet. So this is a true implementation of a microsegmentation security framework. It's done right on the receiving workload interface. Finally, kind of the last trick we have up our sleeve is policy-based routing. You will hear this called service chaining in SDN. It's basically the same thing. And if anyone wants to try and convince me otherwise, I'd love to hear their arguments. We are essentially, with service chains, overriding the routing decision of a packet and instead telling it to go somewhere else, somewhere that we choose. In Tungsten Fabric, the service chaining framework is incredibly open-ended. You basically, as part of your network policy, give Tungsten Fabric a list of VMs or containers that you want the traffic to detour through. Tungsten Fabric will silently and invisibly remap the next hop of traffic destined to, in this case, the yellow network, that Y3 VM, will rewrite the next hop so that the only viable path from B2 to Y3 is through that service instance. Tungsten Fabric makes no opinions about what a service instance is, other than it must be a VM or container, and ideally it has two interfaces, an input and output interface. Other than that, there's no set of VMs or containers that are compatible or certified or any of that mumbo jumbo. As long as the virtual network functions prescribe to the standard set of networking behaviors expected out of virtual machines, then everything will work fine. So There's no particular vendor or solution that works best. My absolute favorite trick for service chaining is still to use a Linux VM running a ImageMagick to invert images of web traffic. It's less good of a party trick now that everything is HTTPS encrypted, but still makes for a good demo. And then we expose all of the configuration, like when I talk about network policy or managing the various objects inside of Tungsten Fabric, we expose our configuration two ways. There's the UI, where you can do all of your centralized config, or we present an API interface that's consumed by automation tools and our Python library. So Tungsten Fabric is really easy to script and to program and to do really cool stuff with. The final thing I should mention while we're talking about handles here or user interfaces is that you can configure a lot of the orchestrator specific features of Tungsten Fabric through the OpenStack Horizon UI or through the Kubernetes API and all of its associated interfaces. And that's because we expose all of the primitives, the networking components of Tungsten Fabric through the orchestrator. So like OpenStack users can still self-service networks and security groups and routers and floating IPs. The Tungsten Fabric UI acts as a way to configure all of the kind of bespoke and special things that TF does. And the last architectural thing that I want to talk about real quick, and this is going to be super important as we're talking about the installation. So in this diagram, I think folks like to start from the bottom up to understand what's going on in the compute nodes. I always like to start from the top down because it makes sense where our config comes from. And it's actually the most important part of Tungsten Fabric is up here at the top where it says orchestration nodes. That's the TF orchestrator plugin. So this is our Neutron plugin, our Kubernetes API plugin. This is what actually calls a lot of the shots for Tungsten Fabric. Just when there's, especially in Kubernetes, when there's just run-of-the-mill pod add deletes, that's going directly to Tungsten Fabric via the CNI and then affecting change in the configuration of TF in the controller. Those plugins are ultimately just REST clients to TF. So, just like your automation tools, the Neutron and Kube Manager components also remotely configure the state of TF. The controller is kind of the central brain of the operation. This is where all of the control complex lives. So all of the config modules, control modules, analytics, stack, everything lives on the controller node. And this is where you'll also find the web UI. So if you log in and make configuration changes, that's via the controller. The controller fans out all of the configuration to the relevant compute nodes in the cluster. So the compute nodes run a teeny tiny little configuration component called agent. Agent is responsible for talking to the controller, grabbing the config and pushing it into the data plane. And the data plane, everyone's favorite part or least favorite part, whatever, you have strong opinions about it. It's called vRouter. vRouter is that kernel module I was talking about that lives on the compute nodes. And it's really important to understand vRouter is a kernel module that adds networking capabilities to the Linux kernel. It does not, like vRouter is not a container. It's not a VM that performs routing. It's a KMod that does this stuff natively. And it also, while it relies on some of the components of the Linux kernel, like IP tables, it tends to create its own structures for everything. So like inside of vRouter, you have your own VRFs, your own network namespaces, if you will. You have your own flow policy enforcement. So you have your own firewalling. vRouter does a lot of its networking itself. So you don't need things like bridges or OVS to do networking on the host. The vRouter is also responsible for managing all of those tunnels. So when we create tunnels across our data center, it's vRouter who's doing the encapsulation and decapsulation. So yeah, understandably, people always want to understand what vRouter is because it's confusing and does all the work. But, I like to talk about the person who talks. Don't draw too much from this. In terms of what we're going to be deploying today, Tungsten Fabric is a containerized architecture. It It's based on the patterns found in the OpenStack Cola project, although it folds neatly into a Kubernetes microservice type environment as well. And there's three main functional blocks of the Tungsten Fabric deployment. Those are the analytics DB, the analytics complex, and then the config and control module. These represent kind of the big macro blocks that you would want to scale independently in a large cluster. And so for like clusters where analytics is a paramount concern, for example, if you're doing billing or attribution in the platform, having a larger analytics DB or a separate analytics DB and analytics API are a good idea. So you can put those onto their own nodes. You can scale them independently of the other processes in the cluster. Similarly, the config and control module can be placed independently. That's, I mean, for folks who have very, very large API scale. I don't actually, okay. So I call out here, but I don't include a really important part. So the deployer that we're going to talk about today, Ansible deployer, and ultimately all of the other deployers as well, but it's most visible and obvious in Ansible deployer. These deployers use load balancers to load balance traffic into the various containers performing a function. So if you have a whole whack of API servers, you'll need a load balancer to spray traffic into them. Ansible deployer is really handy. It sets up an HA proxy instance for you. So if you do have a lot of controllers, you can use HA proxy to basically pin up a virtual IP or a VIP, and then you can direct all of your traffic to that VIP. If you have high scale deployments, there's nothing that says or even recommends that you should use this instance of HA proxy. You can use any load balancer you want, including like a standalone compute HA proxy instance, so not embedded in the cluster, or you can even use, big metal or big virtual load balancers. It doesn't matter. But with the architecture of Tungsten Fabric, you do need to load balance traffic across all of the containers if you want to benefit from the scale. On the compute side, vRouter itself is containerized. So there's a dropper container responsible for downloading the kernel module and inserting it, as well as a container responsible for instantiating the node agent process that I talked about. That's the little container responsible for distributing config. So that is the architecture and what it does. Let's talk about how we get it onto a node. Because there's been a lot of deployers over the ages of OpenStack, of Tungsten Fabric, and all of the projects that came before it. So where do we fit? I'm going to talk today about my absolutely favorite deployer, the one that I've gotten the most mileage out of, and the one that I think represents the easiest way to get a Tungsten Fabric cluster going. There's a bunch of folks who have Ansible deployer OpenStack running in production, so I feel pretty vindicated in my opinions. But you should check it out as well and see if it works for you. You can find the TF Ansible deployer on GitHub. We'll take a look at the repo in a second, but the most important link that I wanted to throw up here is the location of the Ansible deployer container. So we'll talk about Ansible deployer in a second, but I wanted to just point out and have this link up for a minute. I wanted to show that this is containerized, even the deployer, and that's really important as you're working with complicated stuff like the deployer. You don't have to build a deployer instance. You don't have to manage the dependencies of OpenStack Cola, and some of these dependencies are getting a little bit old. I'll talk about that as well. So containerizing it will save you so much time. So just save yourself the stress and aggravation. Use the container for deployments. And I apologize, it took me forever to find this. We do an absolutely terrible job of publishing the location of such a useful tool. So as part of preparing for this presentation, I put a hit list together of things I want to change in our documentation, and this is going to be number one. It's on the slide. You're going to see it in the docs, by the end of the week. So this is the repo for Ansible deployer. despite a bunch of stuff not changing, Ansible deployer is pretty actively maintained. We keep it current, at least for what it can deploy. And if you take a look, Ansible deployer is really a three-step process. You can see it at the end of this. The three steps are configure. I'll embiggen this as well. Sorry, I wasn't thinking. There we go. A little bit more. Okay, so hopefully everyone can see this better now, and I haven't just made the problem so much worse. I think I made the problem worse. Okay, that'll do. So it's a three-step process. Once you have your instances.yaml, which is your config file for Ansible deployer, you feed that to this set of playbooks. And roughly the steps are configure instance, install Contrail, and install the orchestrator. This is actually backwards. We should almost always, like in Kubernetes setup, you can do it this way. Kubernetes will hover at a not ready state until its networking is installed. But for OpenStack, you should almost always do install OpenStack, then install Contrail. In the repo, you can see there's a breakdown of the various nodes and node types. You can see for the macro roles, what containers they actually roll out. So you can see if you add the config DB role to a node, you're going to get an instance of Cassandra, a Zookeeper, and a Rabbit. Congratulations on your strange menagerie. And then on the config side, you end up with a little bit more boring, a set of containers, things like Node Manager, API, ServiceMon, DeviceMon, and Schema. These are the big macro blocks that you kind of lay out when you're designing a cluster. So like when I was saying, you can scale out your, analytics DB. This is what will be in your analytics DB. This is a super important part of the documentation, and it's not called out clearly, or at least there isn't a great example of it. But as of Tungsten Fabric 5, we made the analytics complex completely optional, except for the analytics API. So you need the API server to respond. Everything else is optional. And if you whack the analytics complex, well, some of your cluster gets harder to troubleshoot, but it gets a heck of a lot smaller. So with the analytics installed, I tend to make my controllers somewhere around the 8 gig mark. And then my vRouters, I try and keep above like 5, 6 gig, maybe 4 if pressed, and that'll run. Without analytics, you can run these things tiny. You can run 1 gig compute nodes. You can run like a 2 or 3 gig controller, and everything will run stable. So it's totally up to you. For lab purposes or for POCs, or if you just need something cheap and cheerful, like in my Kubernetes clusters, I tend to not run analytics just because there's other places in a Kubernetes cluster I can get analytics data from, and I can centralize those off cluster. So just keep that in mind. If you're looking for something a little bit more sporting, you can drop all of the analytics components. The other thing that went on my hit list is updating this document because these prereqs are not accurate anymore, but they're not wrong. We have a big problem in Ansible deployer that some community members have been pointing out for the past month or so, probably longer than that. There's a lot of CentOS 7 still baked into our deployments and deployers, which is a problem because that distro we're in polite company, so I will say it has gone through schismic change and now necessitates severe updating. And CentOS 7 is just old anyway. So the good news is that the examples I'm going to show you today were tested on an Ubuntu 2004 install. So I think that's focal. My brain doesn't work this early in the morning, and I just got so excited for 2204. My brain stopped working. I think it's focal will work perfectly fine. And then we're working on some jammy integrations as well. That's 2204, or the best named Ubuntu release ever, Jammy Jellyfish. So expect that to work really soon. The Ubuntu ecosystem in Tungsten Fabric leverages dynamic kernel modules. So with Ubuntu, as long as you can get the user land up, you can generally create yourself a kernel module and it will most likely work. I will say as well, while we're talking about old Linux, that the containers themselves have been updated to a CentOS 8 base. And in some cases, we're using Red Hat's UBI 8. So there should be a flavor of both. So either way, the containers themselves, that which you are deploying is modern. So you're not going to be deploying CentOS 7 containers. But this is what I was talking about. The Ansible deployer container itself has some old stuff in it. Like it has a Python 2 dependency. So I've taken notes. We're going to need to have a community focused project on just pulling up our socks on Ansible deployer. But I mean, our LCM folks and the folks who contribute around the space are incredibly strong. So I have no doubt that we'll get this resolved super quick. But it's definitely something weird. I tend to showcase a lot of bare metal installs. I'm trying to see where this is shown. Yeah, so here. So Tungsten Fabric Ansible deployer works exactly like Cola Ansible deployer in as much as you can give it providers, basically infrastructure modules to connect to, such that the deployer can instantiate its own VMs. I have always been super skeptical of these integrations. I don't like an installer creating and destroying VMs for me. It's that last part that bugs me the most. So you will see almost all of my examples use this BMS example. A BMS example, or pardon me, a BMS provider is a bare metal server. It's not particularly well named because there's nothing bare or metal assumed about it. It can be any type of endpoint. Basically, BMS means that the installer will SSH to a Linux machine that is presumed to already have been installed and working, like basically connected to a network. And that's the right level of integration for me, because then I'll use my VM automation tools to create, heat stacks or to create VMs in KVM or wherever I'm stashing this stuff. But it's a separated process to get all the infrastructure stood up. Of course, you could just think I'm an old fuddy-duddy. I have been called a stick in the mud before. Maybe my opinions are outmoded. If so, you can use the other providers like KVM to connect to a KVM hypervisor and provision your VMs for you. It's totally fine. What you do with your time is your business. I won't judge you. But this has always freaked me out. And then, of course, there's some other cool ones as well. Like you can provision stuff in AWS if you want, GCE. I think there's a couple other infrastructure providers that aren't on the docs. So, read through the specific modules and you'll see them there. But yeah, you have a lot of options. If you actually want to programmatically control the infrastructure and instantiation, you can, or you can be, an old stick in the mud like me and just use SSH. I think that's it. That's all I wanted to show you in GitHub. So let's look through instances.yaml. So let us assume for one brief moment, or let's play pretend for one brief moment, that you have installed your you've created your virtual machines or your bare metal servers. You have instantiated your environment and you have the Ansible deployer container downloaded. What now? So you would connect to your Ansible deployer container. So just Docker exec into that guy. And you would start preparing the instances.yaml file. Instances.yaml is the config for Tungsten Fabric's Ansible deployer. And if I've shared the right window, you should be seeing what its config looks like. So this should look really similar to what we just saw on the GitHub. It is a giant YAML file, but in this year, 2023, YAML is everywhere. So hopefully this is all less scary. And it is sorted into a couple major blocks. So the first block, global config, we just tell Ansible deployer where to get the containers from. For Tungsten Fabric, this will be an insecure Docker registry, hub.docker.io. So you can get the latest TF containers on or directly from Docker. We're not a rate limited project because we are affiliated with an official open source project. So your install should not break for that reason. Under the provider config, this is how we tell Ansible deployer how to talk to our infrastructure. And remember, like I said, I'm an old fuddy-duddy, so it's always going to be SSH for me. So for me, I have to give an SSH user and a super secure password. Don't hack me. Or you can use SSH keys if you're feeling more secure. Give it some fundamental characteristics of your lab, things like the domain suffix and the NTP server, and then you're away to the races. Then you need to define your actual instances. So this is the instances section contains all of the infrastructure that you're going to run your Tungsten Fabric environment on. This contains like the IP address you're going to SSH to, as well as the roles that you're going to roll out with this particular run. If you remember the big blocks that I showed you on the GitHub, that's where those get used. So you've got the web UI block, analytic, like I've left analytics on because I like pretty charts and diagrams here. So analytics is on, then you've got config control and the config database, as well as this guy. OpenStack represents the controller processes for OpenStack. So alongside this run, we're going to install OpenStack Cola on these nodes. This OpenStack role means that this node is going to be the controller. If we zoom down, we've got, oh gosh, I'm the worst. If we zoom down to the next one, we've got compute 2 here. It is also a BMS, so we're going to tell the installer to SSH into it. And this is an OpenStack compute. And to provide networking to our OpenStack compute, we have given it the vRouter role. Now, I'm trying to see if I have a good example. All of this stuff that I have here, like a normal vRouter role should look like this. It should just be vRouter because you don't have a lot of parameterization in a standard vRouter rollout. What I've left here, because this tortured me for ages, and I always figure I'm going to try and save someone else time. So actually, that was a lie. Sorry. Let me delete this again. Let's do this over. This is a standard vRouter config. So you give vRouter the physical interface that it should bind to. So vRouter is going to take over the EM1 interface and turn it into vhost 0. And then you give it the gateway that vRouter should use as the default gateway for the subnet. The reason that we do this is if a compute node has multiple interfaces, say a management interface, an SRIOV interface, and then an underlay connected interface, this lets you say to the deployer which one it should use for the overlay. Now, all this stuff that I just deleted, I want to share with you all because this drove me crazy for a while. You see, Ansible deployer can also set up SRIOV on your nodes. SRIOV is a really super cool way to connect virtual machines to an underlay fabric for super high performance networking. The only drawback being is that you lose all of your cool SDN features. So no more Tungsten Fabric for you, but as an upside, you get underlay networking. I like to use this for like running BGP routers and stuff in my cloud. Because they use SRIOV, I can connect them direct to my underlay fabric. They look like they're just physical routers. It's a cool magic trick. In this section, you define the interface that you want to use for SRIOV, the number of virtual functions that you're going to reserve or pre-create. And this is the most important thing right here, the SRIOV FISNet. We map in Tungsten Fabric, we map SRIOV to FISNets, to provider networks. So if I were to go and create a provider network in OpenStack now that corresponded to FISNet, it would allocate me a virtual function off of this NIC on whatever node this landed on. You can think of FISNet as a logical group of SRIOV interfaces across your compute estate. So the FISNet group represents interface P1, on compute 2, it also represents interface P3, P1 on compute 5, and whichever node that your VM gets scheduled on, if it asks for an SRIOV VF from FISNet, it will talk through these NICs. You can, of course, add SRIOV post facto to a running OpenStack cloud by by modifying the Nova and Neutron config, but it's just so much easier to do as part of the install. We get to the final section, which is embarrassingly called Contrail configuration. This is the actual config callouts for where this is not the right version of this file. I'm sorry. Should say this. There we go. There we go. So in this configuration section, you give TF a view of where its controllers are. So you're telling each set of vRouters where to talk to. Some important stuff like where Rabbit is and what port it runs on. These are some convenience configs. Basically, the node manager for each of the processes, database config, and config, will monitor how much available disk space there is. And if there's less than the specified number, the process won't start. This is obscenely frustrating for labs because disks are normally quite small. So I just set this to 2, so I never, ever see this warning, and it never grenades my cluster. You can set this to whatever you want. I think it's 40 by default, which is insane. Like, that's great for production, not so great for labs. So yeah, get a screenshot of these, or I can put them in the slides, or whatever's easiest, but save your time, save your frustration. The version is the container tag. So set the container tag and the version. 2206 is the latest version of TF. I looked, I couldn't actually see the 2206 release tag. I saw 2206 RC. So we're just checking the repos right now. I don't know if this got deleted during a migration or somebody, like I'm sure I goofed somewhere. So if this isn't working anymore, we'll put it back, or we'll fix it if it never was. But right now, what's in the repos is this. So if you go to pull this in the next 5 minutes, I think it's -RC. So this will be 2206, and then there's a 23.1 that's getting published shortly as well. In terms of the configuration, the last important thing is which encapsulation you want to use. If you've got switches that speak EVPN and VXLAN, you're going to want VXLAN first in the priority, or else MPLS over UDP is generally considered the best overlay encap. And then finally, the last important thing is the OpenStack release. We just went through an exercise looking to see where our OpenStack Z support was. Turns out we've never added it because we didn't have anyone asking for it. So the latest release that I've tried up to, and I did this before this presentation, was Train. I have a feeling Yasuri works as well because, I've been going on about how much I like Ansible deployer, and I do like Ansible deployer. The other deployers that we have for Tungsten Fabric are the charms. So you can deploy an OpenStack instance from Canonical or a Kubernetes instance from Canonical using the OpenStack or the Kubernetes charm. The charmed instances, or the charmed flavor of OpenStack, goes up to Yasuri. So I'm pretty sure we've got it in Ansible deployer as well. But either way, check out the charms, and then I'll be updating our documentation around Ansible deployer to whatever the latest version is, whether it's Train or Yasuri. And then long-term, we want to get Z support and get caught up again. I think A is for Antelope, and I don't remember what the release timeline is for that. So we'll have to just keep an eye on the latest versions of OpenStack, which are Antelope and Bobcat, and make sure we stay up to speed with that. The last thing that I want to talk to you all about is the documentation. We've made an effort to make the documentation for TF better. There's a lot more work to do, but we're focusing on a very important part of it. I absolutely love how I can share a new window without stopping to share. Go Zoom. Okay, so in our docs, if you look at the tree, you'll see right off the bat, the release documentation is the first thing that comes up, and then all the other important things. If you click on the documentation and check out the release notes, you will find this handy dandy table, supported platforms and versions. This table tells you what OpenStack versions that we've qualified against. It also tells you what kernels that we've been successfully running against. This is for 2104. I'll get the 2206 table posted. But whenever you're doing a TF install, pay attention to the kernel versions that have been qualified. This will be your happy path. So, for example, 20.4, like, and again, it's what kernel module works is what you're reading for. So I try not to read too much into the table. You can deploy on 2004.3 without too much headache or heartache, and you know that the 54092 kernel will produce a happy kernel module. Like, that's what you really should be reading for in this. So like my train install is on 20.04.5 and running 54135 or 540.135, and that's another happy path. So this is my kind of third takeaway from preparing this presentation, is just updates required to the supported platforms tables and the getting started guides for Ansible deployer. Okay. And that was a lot of YAML. But once we have our YAML, the installation is actually pretty darn simple. I know, famous last words, but you run 3 commands to install Tungsten Fabric and Cola Ansible deployer. You install you run configure instances. Configure instances is responsible for configuring the instances. It does like DNS, NTP, package management. So like things like the required Python libraries on every node, like pip. I think that's about it. Oh, I think the SRIV virtual functions get provisioned as part of configure instances. The most important thing about Ansible deployer, especially right now, like there is a rough edge in Ansible deployer as it pertains to pip and Python 2. If you see Ansible deployer failing because of an unmet dependency, you can, and because Ansible is idempotent, you can go into the nodes and resolve the dependency issue yourself. We will be fixing Ansible deployer, but for example, in Ubuntu 2004, there is a big problem with pip2 right now. So you have to install pip2 yourself, and then the Docker Compose module, and then everything will work fine. We will be submitting patches and ultimately getting Ansible deployer back into good shape. But like it's again, the nice thing about Ansible and it being idempotent is if there is something in the automation that works, you can go fix it. So yeah, you run configure instances. Maybe you installed pip2. Then your cloud is configured. The install OpenStack command pulls down Cola. There's an install Kubernetes command that pulls down upstream, or command playbook. So there's an install Kubernetes playbook that will pull down Kubernetes and install the orchestrator for you. In general, I always run it in this order: is configure, install the orchestrator, and then the awkwardly named install Contrail YAML. This is going to install the Tungsten Fabric containers and plumb it into whatever your orchestrator is. And the orchestrator environmental variable controls what gets deployed. And that's it. I think that's even my last slide. Yeah. So Ansible deployer, like I said, it's still the best way. Sorry, I'll leave it here so you can get screenshots, or this is in the recording. But Ansible deployer is still my absolute favorite way to deploy Tungsten Fabric. I've been incredibly lucky with it. It almost always works for me. And when it doesn't work, pip2, looking at you, there's ways to get around that and fix it. It's compatible across the broadest set of use cases, so you can deploy Cola OpenStack HA or single node standalone. You can deploy a remote compute cluster, so like an edge compute deploy can be built with Ansible deployer. It really is incredibly flexible and very, very powerful. And there's a bunch of Kubernetes stuff in there as well, so you can also roll out a Kubernetes cluster. Although the 2 other mechanisms that we have for deploying Kubernetes in Tungsten Fabric, and I mean, we should do a deep dive on this next DTNF. We have our TF operator, which is an operator for running Tungsten Fabric inside of a Kubernetes cluster. And then we also have our whole pile of manifests, which is kind of just the simplest and most complicated way to deploy Tungsten Fabric on Kubernetes. If you like this, if you have questions, jump into the mailing list, join us at the TSC meeting, or hit us up on Slack. We are definitely a community of operators and users. So, we're still working on bringing back more voices to the engineering community, but there's a lot of expertise in the Tungsten Fabric user community. So yeah, please reach out and interact with us all there. But moreover, thank you for your time this morning, this afternoon, this internet, whenever you're watching or consuming the video. It was fun to talk through some of the cooler points of TF. And of course, in the vein of open source, I found a lot more work that we need to do along the way preparing for this talk. So not only has the talk hopefully made you all a little bit better informed, but will make the project better as well. I'm going to stop the share, and if there's any questions or comments, I didn't think there were so many people who came in. So hi, folks. We'll hang around for the next, call it 4 or 5 minutes. If there's questions or active discussion, just let me know. There's no prizes. There's no prizes for asking questions. And thank you. If there's any stuff that pops to mind, jump into Slack or jump into the mailing list. But yeah, no, thank you again for the time. Oh, the other thing I should say, and then I promise I'll stop talking, or at least for 10 minutes. We have a follow-up meeting after this with some of our community and engineering leads. So if you are curious about Tungsten Fabric, if you want to know how to contribute, or if you want to talk to the people who run the engineering engagement, stick around at 8:30 Pacific time. We will have a couple more TF maintainers around to ask questions.
That's in about 10 minutes, the next session, for those of you who are not tracking Pacific time.
Thank you, Mr. International. Casey has a wall of clocks. Sorry.
It's more like a Stream Deck.
Full of clocks, like an old-timey stockbroker.
Yeah.
All right. Everyone's rushing off to Amazon to get a wall of clocks. But yeah, thank you. I'm going to go freshen up my coffee, and I will rejoin this bridge for our developer chit chat. And thank you again to Casey, Kenny, and the entire Linux Foundation for giving us this opportunity. It's always fun to learn and to chat in these forums. So thank you all.
And I will just drop a quick reminder that for those of you who did not register, please go ahead and register for this event. It is free, does not cost anything, but it helps us with making sure that we are planning these events appropriately, and gives us important data for the future events. In addition to registration, which I just dropped a link into the Zoom chat for, you can also continue to view the schedule, which is linked here. Again, the next session, as Nick just mentioned, starts in about 8 minutes, where they'll be talking about some future development, Tungsten Fabric. And of course, we also have a operations survey. We're asking that everyone please take an opportunity to fill out the operations survey if they get a chance. This operations survey, in addition to helping us plan our events in 2023 and 2024, will also help us better serve our communities. So the link to that operations survey is right here, is the third link that I dropped into the Zoom chat for you. And with that, we'll take about a 7-minute break, 6-minute break, and then we'll start our next session here.
Recording still running.